Hey everyone, and welcome back. We are going to dig a little bit deeper into how PythonTutor sort of diagrams and illustrates objects in Java, and we're going to talk a little bit more about how memory is allocated and sort of how all of that fits together and helps us in our code. Now, just to start out, I'm going to give myself a class here. I'm going to leave those out for right now, I think. And I will, add a constructor with the name and an age for a person. We can set each of those variables. This instance variable will equal the local variable. There we go. All right, just as a quick reminder, I'll put it like this. Make your fields private. I'm leaving them public for right now, but they really should be private when you're writing code that you're going to submit, or maybe code that you write in the workforce, stuff like that. So let's just start by making a main class and looking at one person object here and just kind of trying to understand where Java puts everything and get a better lay of the land for that initial object. All right, there we go. Let's start with a new person, and we will call her Alice. There we go, and we'll just, for ease, also add a print line in here. Print line Alice.name is, let's see how old she is, Alice.age. All right, let's visualize this. And let's see what it actually looks like in memory. So we'll just let this take a second to boot up. All right. And we start our code off by running right here on person Alice. We're going to make a new version, a new object, right? A new instance of the person object. Right there, we call that very first line. We've now allocated this new keyword, allows us to allocate the memory we need. So we've made a string name and an int age. You'll notice that name is null by default and that age is 0. Once we run lines 6 and 7, these will get set to Alice and 20 as we'd expect them to be. When we come back into main on line 14, which we haven't run yet, but we will in a second, we'll get it all to print right out and our code will be done. Now, notice that the variable Alice is living in the current stack frame right here. The person object with its fields live over here. That's because this is representative of stack memory, and this over here is representative of heap memory. The Alice variable doesn't actually store the values of name and the values of age. It's actually storing a reference or an address to where that information lives over here in heap memory, and that's often depicted with an arrow. All right, so when we say heap memory, right, what is that actually, like where is this object actually living? Let's talk about this for a second. Let's talk about the new keyword and what it means when we're referring to a new person or a new type of object. So new is kind of like getting a fresh address. The variable here, Alice, it just remembers where that address is. It's just like storing an integer, because we really don't store these big giant objects over here on our stack. They're always sort of being allocated over here in heap memory. This is just like getting an address to a house. So for example, if I live at 123 memory lane and then I invite you to come to my house at 123 memory lane, I'm not copying my house and giving you a copy of my house. I'm just sharing the location where you can find my house. That is exactly what's happening here. Let's take a look at another code segment here. Let's add another person, Bob. Bob can be 25. Let's add another person. Let's get rid of this line. We don't need it for a minute. Also Bob. Bob. All right. Let's do system.out.println bob.age. Oh, don't need that there. All right, let's do this. So we still have Alice. I guess we don't really need Alice for this example, but there's no harm in leaving her code up in there. We can see that we're going to go and create Bob as well. When we come back to main, we can see we have Alice and Bob, each with their own memory being allocated. Now, when we go and run this line next, person also Bob is equal to Bob. What actually happens, as we can see, is also Bob is a variable that gets created, but we're once again just sharing the address. I'm just telling you where you can find Bob's information. So that means both Bob and also Bob point to the same instance of the values of the information. When I print this out, it prints out 25. Okay, let's do some altering here. Imagine for a second that after I did this, I changed also.Bob's age to now be 30. Let's run this code as well. We'll come along here, get us back to Bob being created. Also Bob gets created. There we go. We've got back where we were. Bob, also Bob, both pointing at the same piece of data. Also Bob.age equals 30. Now this is like this variable, this person, is going to go to the address at which it's holding, the address that Bob shared with it, right? And it's going to mess up the house. It's going to change something in the house. So we go, also Bob goes to the address he's holding and goes to age and alters it. And what do we see? Well, we see it changed it to 30. And what does that actually mean for Bob? Well, when Bob comes home later, Bob comes home and tries to print out his age, he's going to find his age has changed. So change to also Bob affected the Bob variable. And this is known as aliasing or shallow copies. We would have seen this before when we talked about like array copying in 1010. This is because they're both pointing to the same heap object. If you didn't take 1010, or perhaps you don't remember what would have been done in 1010, we can take a quick look at that right here. 1, 2, 3, 4, and we can make another array. Int array 2 is equal to array, and we'll see that the exact same thing is going to happen. We've got array 1 being created, we've got array 2 pointing to array 1. So now if I make a change in the array or in array 2, we will see that the change affects both of these variables. Now, while we didn't really see it in the previous example, can I go back? Sure can. We'll get rid of Alice since we don't really need her for this example. Whoops. Well, we can't really see it in this visualizer tool. Strings, capital S strings, are also objects, right? We know that strings are objects too. It's one of the first things that we kind of talk about is anything that starts like a capital letter, we basically can consider an object, and Java has this built-in object string. And we could kind of even think about it like under the Java hood, it's technically like an array of characters. It's not quite correct, but it's a way to think about it. Just like a person under the hood is a string name and an int age, a string under the hood is an int length and an array of characters. So Java actually does some interesting things with strings, which is why they act a little bit different than other types of objects. It will in turn literal strings so that sometimes the same literal string, like the word Bob here, could be, it can point to the same object more than once. So for example, string S, Bob. This string S would also technically point to this like Bob.name. Those would have the same value inside Java's string pool. Now, I'm not going to go deep into Java string pool and string literals and what happens there because I do have a whole video about it, which I will link in the description of this video. So if you want to check that out, you absolutely can. What I will show sort of briefly is a string 1. We'll just do hi, and we'll do a string 2, hi. In our visualizer, this will show as 2 separate strings. Thanks to what Java does, it just shoves them right on the stack. It doesn't really do anything. We can see that they're separate, but in reality, if we really want to understand what's going on underneath the Java hood, these are actually technically living. It's a single variable, a single string literal, living somewhere called the string pool, and S1 and S2 reference it. We can also, just like we can with integers. If we want to turn an integer into an object or an int into an integer object, we say new integer. We can do that with strings too. It is an object. We can say new string. We can see what will happen when we do that. All three now say hi, and we can totally see that. Now it's worth noting that if I try to do an equality test like this, now remember, when we do equals equals on objects, we're actually comparing references. We're not comparing the internals. So S1 and S2 will most likely come back as true. Whereas S1 and S3 most likely will be false. Let's take a look and make sure that those print out as we expect. It'd be even more helpful if I put that bracket in there. There we go. And there we go. We have true and we have false. And there's some really interesting reasons why these things are happening. If you wanted these two to come back as true, since they are technically the same word, that's why we use .equals methods, as we have talked about in other videos around strings, and as we will talk about a little bit more when we hit the string topic next week. We'll go ahead, we'll run that, we'll get true, false, true, because now this final one is actually comparing the contents of each string. All right. So as I showed already, we saw some aliasing with arrays when I did array 1, and we did array 2 is equal to array 1, right? Arrays are objects, so the variables hold references to them, and if two variables point to the same array, if we make edits in this one, it's going to affect this one, and if we make edits in this one, it's going to affect this one. We can understand that at this point in time. Hopefully, now that we've sort of shown that on the heap, we see a single array object with both of our array 1 and 2 arrows pointing to it. Now, let's expand on this idea of person for a second and see what else we can do with aliasing. Let's add a spouse. So if we go back to our previous example with Alice, new person, Alice, being 20 years old, and person, Bob, new person, being 25. Something I could do is I could set Alice's spouse to Bob if they got married. Alice and Bob got married. All right, let's take a look and see what's happening here. Oh, I just spelled spouse wrong. There we go. All good. So when we run through this code this time, we set up all of Alice and Bob. We can now see that Alice has a name, an age, and a spouse, and if we follow the spouse reference, we end up right here on Bob, because Alice married Bob, so that makes sense. We can do some really crazy things with that. I could now say Alice, who is an object, dot spouse, which is an object, dot name, is going to now be equal to Bobbert. That says Bibbert. Bobbert. And now through Alice, I'm going to have been able to change Bob's name to Bobbert. There we go. We can see Alice became, over here, we have Alice spouse. So we went to Alice spouse. We went to the spouse's name. And we're about to set the name to Bobbert. Right there, name equals Bobbert. And so what do we see happening? We can access data. Maybe we shouldn't in this scenario. And this is part of why it's important that we remember to make fields private and handle things appropriately. Now, typically when somebody gets married, like Alice just married Bob, it would make sense to say that Bob also married Alice. But right now in this visual diagram, we can see that Bob's spouse is null. It doesn't point to Alice. So what do we want to do? We want to make sure that we also give Bob a chance to say that he is married. There we go. Now, what does this look like when we run our code? I'm just going to let this jump all the way down. And what we'll see is our arrows cross over a little bit, right? Our picture gets a little messy, but that's okay. We can see that Alice's spouse is Bob and Bob's spouse is Alice. And we end up with what actually is called a circular reference because this one references this one and this one references this one. And you can keep going back and forth and back and forth and back and forth. In fact, I can even show you with a really neat little piece of code here. If we have a helper person named Bob, while We better do it a certain amount of times, actually. For int I is equal to 0, I is less than, I don't know, 100, I plus plus. Let's print out Bob's name. Let's print out that helper person's name, system.out.println, helper.name. And then let's make the helper equal to the spouse. It's going to be really wild. 100 is a lot of times, so I'm not going to actually show them all. But I will show a couple. I will show a couple rounds of this. All right, I can put a little breaker there. Oh, I ran over where I meant to go. Okay, so now we have our circular reference all set up just as we had before. And now let's watch and see what happens. We're gonna go through next and we print out Bobbert because our helper was Bob. Helper was also referencing Bob. So it went to the name right here and it printed out Bobbert. Then the very next line to run will say helper is now going to be equal to helper.spouse. So let's follow our arrows. What is helper's new reference going to be? Well, it's going to go to helper. It's going to go to helper spouse. And then it's going to be whatever value is in here, the memory address for Alice. And so now our helper arrow, as we just saw, changed because now it's up here. And our code will run again. And it will print out Alice. And this time, helper needs to be reassigned again. Where does that helper arrow go? Well, helper is going to be equal to the current helper's spouse. Well, who is Alice's spouse? It's Bob when we follow that arrow. Now I'll jump to the end, and we will see that we just went back and forth. Bob, Alice, Bob, Alice, Bob, Alice, over and over and over again. Kind of cool. Something that might serve us really well later on, actually. So, since we're just referencing addresses all of the time, how do we actually make copies of things? What if I actually do want a completely separate copy? We're going to finish this off now by talking about deep copies. We previously discussed aliasing or shallow copies. Now let's talk about deep copies. Now we could define a couple of different methods right in here. Let's define a method called clone. And what is clone going to actually do? We are going to make a deep copy of this person. Pardon me. So how does this work? Let's go back to our example of just Alice. There is Alice. And let's say we want a copy of Alice. Copy of Alice. What do we need to do? We can call clone on Alice. And we need to return a new person. What are the variables that we need to return? Well, if we're going to return a new, that new being the keyword that gives us a brand new address, what are the values we want? Well, we want our current name and our current age, but we just want copies of them. So by saying new, we're going to get a brand new person object, and we're going to assign it the name of our current person and the age of our current person, and we are going to return that address back to the call. Let's take a look and see what that looks like right here. All right. So we've got Alice being created, and then we have this person copy of Alice equals alice.clone. So Alice goes into the method alice.clone. We're right here. We can see that we're inside the clone method. We can see that this object is referring to the same object as Alice. So what are we going to do? We're going to create a new person. So what line is going to run after this? It's a good time to pause and ask ourselves, what line will run next? The right answer, I hope you'll notice, is actually going to be line 6. We're going to go ahead and run line 6 next because we're going to call this constructor on this name and this age. So we jump into the constructor and we end up with a brand new record on our frame, on our stack here, with a name coming from Alice previously and an age of 20. These get set to those instance variables. We're going to come back to the clone method where we now have a return value. And as we can see, this that we called our clone on is Alice. And the return value is an entirely separate arrow. It's going to an entirely separate person, which means when we return back, we now have Alice untouched and copy of Alice right here, completely separate with identical information in it. So we actually have seen stuff like this before, and it makes sense why it works, right? We understand references, we understand aliasing and how we might want to copy something over safely to ensure we're not going to affect the original data point. The last piece of the puzzle around here is the idea of being able to pass things into method parameters, and then we can change those objects without returning anything. If you haven't yet put this whole puzzle together, we're going to do it right now. We're going to just discuss it, but this is something you would have started doing last year, whether you took a Python course or you took a Java course. It wouldn't matter. You would have still done passing by reference, accidentally or on purpose if you didn't know the term before. When you pass an object or an array into a method, Java is giving a shallow copy of that reference. So for example, if we go back to one of our simplest examples here, let's go back to just an int array1. There we go. For each int I in the array, we'll just print it all out. System.out.println I. There we go. And then let's call a method change index to another number, and then we'll print it again. Oh, I better pass in the array too, array1. All right, let's write this method, public static void change index. It's going to take in the int array. It's going to take in the index I, and it'll take in the value we're changing it to. And right inside here, we can just say int array I is equal to value. All right, let's run this code just so that we can really understand what's happening when we talk about passing references in. What would be the most helpful is if I actually named everything the way I expected to. Right here. Okay, so we're first going to make that array1, and then we can see, I'm just going to let it jump right over. We can see it printed out 1, 2, 3, 4 thanks to this for loop. Now we're going to go into this change index method. We go right in, and we can see that we passed in our array1, but just by its address, which means that when we now go to change array1 internally, right here, at spot 0 equal to 100, it will also affect the original with no return value. Let's take a look. There we go. We come out of the method. We lose this variable. It was a local variable to the change index function. The one that lives back up in main still exists, and it has the changed value. So now our change value is what's actually going to print out. So we've been doing this for a while. We just never really put a name to it before. And now we can understand it with arrays, and it applies to objects in the exact same way. So we're mutating that object by the reference, and then that way the reference can change that shared state. If we reassign a local parameter, it wouldn't affect the caller variable, right? If we change the address internally, it doesn't affect the outer address. It's only effective if we're actually making a change to that object. So for example, if we just come back to here, if I suddenly had inside this change index method array1 equals something different, then I'm changing this variable. So that means this arrow would move and be pointing somewhere else. I thought I could unclick it. There we go. It would be pointing somewhere else, but what we can see is that doesn't affect the main one at all. The only reason that this actually does affect the main one is because we're not changing what array1 is equal to. We're changing what the values inside array1's reference are equal to. So our variables are holding addresses to heap objects, and that new keyword is what's creating a fresh address. Our aliasing means that we have a bunch of different variables, but they're all pointing to that same object. We had another word for aliasing, could also mean like a shallow copy. And the difference between a shallow and a deep copy is basically what is determining whether we're sharing or duplicating the internals of an object. And all of this isn't actually that new to us, even though we are putting a name to it now, because we've been passing arrays around or lists around if you took Python previously. And passing objects and arrays are basically just copying that reference down so that the methods can mutate the data without returning. We have a really deep understanding now, I hope, of objects and sort of how they're being shown in memory and why it's so important for us to be able to sit down and actually draw it out and understand what it looks like in memory, especially when we start getting into trickier situations where we have circular references like our spousal example, or even just some of this aliasing can get kind of tricky. With that, we're closing off this idea of basic objects and sort of objects 2. Be sure to do lots of practice, and I'll see you in my next video set. Thanks. Bye.